So what if the end of the universe, doesn't actually come with fire or giant asteroids or a collapsing sun?
Right, no giant explosions.
Exactly. What if it happens in absolute silence, traveling at the exact speed of light, and hits us before we can even blink?
It's a genuinely terrifying thought.
It really is. Welcome to today's deep dive, everyone. We are looking at a stack of notes today from Ziko Space Stories, and we're unpacking a concept that sounds, honestly, like a late-night sci-fi movie. But it is actually deeply grounded in advanced quantum physics.
Yeah, very much so.
Our mission today is to explore a phenomenon known as vacuum decay, which is essentially an invisible bubble that could theoretically erase our entire universe. When I first read this, I thought it was just science fiction. How can reality just pop?
I mean, it's a completely natural reaction to have. It forces us to completely reevaluate what we consider, solid and permanent.
Right.
We operate under the assumption that the fundamental rules of reality are fixed. But the physics we're exploring today suggests those rules might just be a temporary condition.
Which is just so eerie to think about, because when you look at how we usually conceptualize a doomsday event, it is always highly visible, right?
Oh, absolutely.
It is steeped in classic cause and effect. If a star goes supernova, it releases radiation that we can detect.
We can see it coming.
Yeah. Or if a rogue asteroid is on a collision course with Earth, there's a physical object we can track through telescopes.
Exactly.
There's a sequence of events, like a buildup, and usually a frantic scrambling of scientists trying to solve the problem.
Well, cause and effect is the bedrock of classical physics. I mean, we expect destruction to announce itself because destruction, as we know it, is a process.
A process, right?
Yeah, it's a transition from an organized state to a disorganized state over time.
Yeah.
Like a building crumbles or a fire burns through a forest.
But vacuum decay completely subverts that whole framework, doesn't it?
Completely.
If I'm understanding the physics outlined in Ziko's Space Stories correctly, we aren't talking about a physical object physically smashing into another physical object here.
Right, no space rocks.
So instead of watching the TV explode in a shower of sparks, this is like someone just yanking the power cord out of the wall. The picture just vanishes.
That power cord analogy perfectly captures the nature of this threat.
Yeah.
A standard apocalypse destroys the physical things within the universe, the planets, the stars, the galaxies.
The stuff we can see.
Right.
Yeah.
But vacuum decay destroys the underlying rules that allow those things to exist in the first place. The source material describes it as an event so fast and absolute that the transition from everything to nothing involves zero buildup.
Wow. Zero buildup.
None. There's no heat wave, there is no structural collapse, there is just the immediate absence of reality as we understand it. Before everything you know ceases to exist, there is just complete nothingness.
Okay, let's unpack this, because if the universe can be shut off by yanking a power cord, we have to look at what that power cord actually is.
Exactly.
What is generating the rules of reality? The notes point directly to something called the Higgs Field. I know this is a concept that gets thrown around a lot in popular science, usually in relation to the God particle, but let's break down the actual mechanism here. How does a field dictate reality?
Well, we always tend to assume that empty space is just a void where things happen.
Right, just emptiness.
But vacuum decay reveals that the empty space between matter is actually the main character. The Higgs field is an energy field that permeates every single millimeter of the universe.
Okay.
You can't see it or feel it, but as fundamental particles like quarks and electrons move through space, they interact with this field. And that specific interaction is the mechanism that generates mass.
So without that field, particles wouldn't have any weight or substance.
Exactly. Think of the Higgs field like a room packed full of paparazzi.
Okay, I like this.
Right. So if a very famous celebrity tries to walk through that room, the paparazzi swarm them. They grab at them, ask for photos, and slow the celebrity down. That resistance, that sluggishness, is mass.
Ugh, got it. Heavy particles interact strongly with the field.
Yes. Now, imagine someone who isn't famous at all walking through the same room. The paparazzi ignore them completely. They can run right through the room at top speed without any resistance.
Oh, and that is what a photon, a particle of light, does.
You nailed it. It doesn't interact with the Higgs field,
Okay.
so it has no mass, and it travels at the absolute speed limit of the universe.
So if that paparazzi room suddenly vanishes, or the rules of the room change, the celebrity and the nobody are suddenly treated the exact same way.
Right.
If the Higgs field shuts off or changes its value, the fundamental particles that make up your body just wouldn't have mass anymore.
The electrons would stop orbiting the nuclei of your atoms. The atoms themselves would instantly unbind. Every single particle in your body, in the earth, and the sun would suddenly be free of that sluggishness and would instantly zip away at the speed of light.
That is just terrifying to visualize.
It is.
Hmm.
Matter, chemistry, biology, none of it works without the specific resistance provided by the Higgs field. The stability of our existence entirely depends on that field remaining exactly in the state it is in right now.
Which brings us to the core tension of this deep dive. The notes from Ziko's space stories suggest that this field, the very foundation of mass and matter, might be unstable.
Yes.
They introduce the concept of a false vacuum. To visualize this, the text uses an analogy of a landscape with rolling hills and valleys and a boulder rolling through it. Can you explain that false vacuum analogy for us?
Absolutely. So in physics, everything seeks its lowest possible energy state. If you put a boulder on the side of a mountain, gravity pulls it down.
Naturally.
It rolls until it settles into a valley where it can't roll any further down. In this analogy, the boulder is the energy state of the Higgs field. Currently, it has settled into a valley. It's resting there, providing the exact amount of mass to particles that allows stars to burn and DNA to form.
But if you look at that boulder sitting in a valley, it looks completely stable to us. It isn't moving. If the boulder looks stable to us, what could possibly give it a push?
Well, the crucial distinction is whether that boulder is resting in the absolute lowest valley possible, or just a temporary depression high up on the side of a much larger cosmic mountain.
Oh, I see.
A true vacuum would mean the boulder is at the absolute bottom. A false vacuum means it is stuck in a local valley, completely unaware that a much deeper drop exists just over the next ridge.
Wait, if the universe has been stable for 13.8 billion years, that feels like a pretty good track record, doesn't it?
It does sound like a solid run.
Right. Why do physicists look at a 14 billion-year-old stable universe and assume it's precariously balanced in a false vacuum? Doesn't its age imply true stability? Why doubt the ground we are standing on?
It's a very fair challenge. We shouldn't assume instability without data. The suspicion actually comes from measurements made at the Large Hadron Collider.
Oh, really?
Yeah. Physicists measured the mass of the Higgs boson, which is the particle associated with the field, and the mass of the top quark, which is the heaviest fundamental particle. When you plug those specific masses into the equations governing the universe, the math lands in a very uncomfortable sweet spot.
Uncomfortable how?
The numbers just don't point to definitive, locked-in stability. They point to a state called metastability.
So the math itself suggests that our valley might just be a temporary ledge.
The calculations imply that a deeper energy state, a true vacuum, likely exists. Our boulder has just been sitting in this high-altitude false vacuum for 13.8 billion years.
But even if there is a deeper valley, the boulder is still trapped in its current valley, right? I mean, in the physical world, a boulder resting in a ditch needs a massive input of energy to roll up and over the ridge before it can fall down the rest of the mountain.
Right, you need a lot of force.
It needs an earthquake or a massive physical push. If there's no cosmic bulldozer to push the Higgs field over the edge, shouldn't we be safe?
In the classical world of cause and effect, you are absolutely correct. The boulder needs a physical push to climb that ridge. But we aren't dealing with classical physics here. We are dealing with quantum mechanics.
Ah, of course. The rules always change with quantum mechanics.
Always. And at the subatomic scale, the rules of reality are fundamentally different. Particles don't always need a physical push to cross a barrier.
Because of a phenomenon called quantum tunneling, right?
Exactly. Quantum tunneling bypasses the need for a push entirely. At the quantum level, a particle isn't a solid dot bouncing around. It behaves more like a cloud of probability.
A cloud of probability, okay.
Yeah, so when a particle is faced with a barrier, like the ridge of our valley, its probability cloud actually bleeds into and slightly through that barrier.
Meaning there is a mathematical chance that the particle is already on the other side?
Exactly. There's a tiny, infinitesimally small, but non-zero chance that the particle will simply transition through the barrier without ever having the energy to climb over it. It doesn't roll over the ridge. It essentially teleports directly through the mountain and appears on the other side, instantly dropping into the deeper valley.
That is deeply unsettling because it strips away our whole framework for predictability. It doesn't require two black holes colliding to trigger it.
Nope.
It doesn't require a dying star. It just takes a microscopic, entirely random roll of the quantum dice, one random tunneling event in the vastness of space, and the boulder slips through the mountain and crashes down into the true vacuum.
And the moment that happens, the energy state of the Higgs field at that specific point in space drops to its absolute lowest level.
Oh, instantly.
Instantly. The rules of physics at that microscopic point instantly change. And because this true vacuum is a lower energy state, it is far more stable than the false vacuum of our surrounding universe.
And the universe naturally wants to move towards stability.
Yes. So that singular microscopic point of true vacuum becomes a bubble. And that bubble immediately begins to expand outward in all directions, converting our metastable false vacuum into the new true vacuum as it grows.
Here's where it gets really interesting, logistically speaking. If the power cord gets yanked, the screen goes black. But the text explains that this black screen expands outward at a very specific speed, doesn't it? The speed of light.
It expands at the absolute speed limit of causality in our universe.
Which raises a major question about our ability to detect it. I mean, wait. If this bubble is destroying planets, surely someone at NASA would see it coming through a telescope and give us a warning, right?
You would think so.
We have the James Webb Space Telescope looking at galaxies billions of light years away. We have observatories tracking background radiation and deep space anomalies. Even if we couldn't stop it, we would at least see the galaxies winking out one by one.
It is a natural assumption because we are so used to the idea of a warning signal preceding an event. Like we see the lightning flash before we hear the thunder because light travels faster than sound.
Right. The visual information outpaces the physical shockwave.
Exactly. But vacuum decay operates at the absolute limit of information transfer. Information in our universe, whether it's light, gravity, or radio waves, cannot travel faster than the speed of light.
Oh, I see. You can't outrun the thing that carries the warning.
You really can't.
Hmm.
The bubble is moving at the exact same speed as the light it is generating or blocking. No light from the collapsing galaxies can reach our telescopes before the bubble itself reaches us. The flash and the boom are arriving at the exact same millisecond. There would be zero warning.
No signs in the sky at all.
None.
So the destruction is essentially riding on the very front edge of the light itself. It makes you wonder, if you're sitting in traffic right now, stressing about your day, does knowing that reality hangs on a fragile quantum thread make you more anxious or strangely relieved?
That's a profound way to look at it.
Because there are no alarms sounding at observatories. You could be listening to this deep dive right now, feeling completely safe, and the very next millisecond, the invisible wall of the bubble just passes through you.
And in that singular millisecond, the Higgs field changes its value. The mass of the particles making up your body changes.
It's ripped apart instantly.
Yes, the atomic bonds holding your DNA together fail. The fundamental forces that hold the Earth in orbit around the sun dissolve. The transition is so fast that your brain wouldn't even have the processing time to register that it was happening.
Just existence, and then not. But let me ask you this. So if our atoms are ripped apart, what are they turned into? What's actually left inside this bubble once the wall passes through? Matter and energy can't just be completely deleted from existence, right?
The law of conservation of energy dictates that it has to go somewhere.
Exactly.
If we connect this to the bigger picture, the matter isn't deleted, it's completely restructured. Vacuum decay isn't a giant cosmic incinerator that leaves behind a scorched universe.
Okay, so it's not just burning everything down.
No, it is a fundamental rewriting of space itself. Inside that expanding bubble, the new rules of physics take over. The delicate balance of electromagnetism and gravity that allows chemistry to occur simply cannot exist in the true vacuum.
So it's an entirely new set of rules.
Completely. The matter is rewritten into a completely unknown form. It doesn't just destroy life, it destroys the fabric of space itself. Gravity might repel. New, bizarre forces might emerge. It is, as Ziko Space Stories describes it, the ultimate cosmic reset button.
It wipes the slate entirely clean. It's not just erasing the drawings on the chalkboard, but dismantling the chalkboard itself and building something entirely alien in its place.
That's a great way to visualize it.
And the detail from the notes that really makes this creepy is the geographical scale of this threat. The universe is unimaginably vast, and it has been expanding for nearly 14 billion years.
Yes, and the sheer size and age of the universe means that there are countless opportunities for a quantum tunneling event to occur.
So, somewhere out there, billions of light years away in some distant galaxy, the boulder could have already bled through the mountain a billion years ago.
It's theoretically possible, yes.
A bubble of true vacuum could have been born before the Earth was even fully formed. And because it travels outward at the speed of light, it could be halfway here. It could be 10 minutes away. This invisible wall of rewritten physics could be heading toward us right now in total silence.
A wave of total erasure sweeping across the cosmos. It highlights how local our perception of safety really is.
It's incredibly eerie. With all of that mind-bending terror laid out on the table, we need to talk about the actual timescale here. So, what does this all mean? Is this something that is mathematically likely to happen tomorrow? Should anyone listening to this realistically expect the universe to hit the reset button before they finish their morning commute?
Well, we can confidently look at the scientific consensus from the source material to provide some much-needed reassurance here.
Good, I think we all need that right now.
While vacuum decay is theoretically possible, and the mathematics of the Higgs boson strongly support the concept of a metastable false vacuum, scientists estimate that the probability of a quantum tunneling event happening in our cosmic neighborhood is astronomically low.
So the boulder is very firmly lodged in its valley for the time being.
For the time being, yes. Current theoretical models suggest that we might not have to worry about this happening for tens of billions or perhaps even trillions of years.
Trillions with a T.
Exactly. The universe will likely face many other entirely different cosmic milestones, like the burning out of all stars, long before the Higgs field ever decides to spontaneously slip into a true vacuum.
Okay, so we can probably finish this deep dive without reality collapsing. But even knowing that it likely won't happen for trillions of years, the philosophical takeaway from these notes is incredibly humbling.
It really is.
We go about our daily lives treating our reality as if it is permanent and unshakable. We build skyscrapers, we study history, we assume that the ground beneath our feet is a fixed constant. But to realize that our entire existence, every star, every planet, every memory, is essentially just a temporary holding pattern hanging on a fragile quantum thread, it profoundly shifts how you view the universe.
It reveals the architecture of reality to be far more delicate than our daily experience suggests. But there is a final, deeply provocative thought that stems from this entire process, building on what the source material touched upon.
Oh, I love provocative thoughts. What is it?
Well, we established that if this true vacuum bubble passes through, it completely rewrites the laws of physics. It creates a realm where our specific chemistry simply cannot exist.
Right, a completely new operating system for the cosmos.
Exactly. But a new operating system still has rules. It still has energy, and it still has interactions, even if they are entirely alien to us. So if that new universe expands and stabilizes over its own trillions of years, could those new bizarre forces eventually give rise to a completely incomprehensible form of life?
Oh, wow. A complex biology based on physics we can't even dream of.
Exactly. And if those beings eventually develop their own science and mathematics, they might look back at the origins of their universe. They might find the mathematical echoes of our reality and realize that their stable universe was born from the collapse of a previous, highly unstable state.
A universe built on the ashes of our physics.
Right. They would look back at our 14 billion years of history, our stars, our galaxies, and view our false vacuum as nothing more than a fragile, temporary illusion that had to shatter in order for their true reality to begin.
We are just the prequel to a universe we wouldn't even be able to comprehend. That is a truly fascinating shift in perspective.
It really makes you think.
It does. Thank you for joining us on this deep dive into the absolute edge of quantum mechanics. The next time you walk into a room and slip on the light switch, take a second to appreciate the fact that the underlying power cord of reality is still plugged in, and the bizarre machinery of the universe is still holding steady. Keep questioning the unseen rules of the world around you.